Hello all, in this video I'll tell you how to create your first LED blinking program using your PIC microcontroller and XC8 compiler. If you're completely new to this video, I would recommend you to visit circuitdigest.com and read over the PIC tutorials over there. This will be the second tutorial. If you could read the complete write-up, it will be better so that you'll get to know what's happening in this video. Now let's get started. I'll launch my MPLABX IDE. It's getting booted up and here it is. So this is how your MPLAB will look once it gets launched. Now let's create a new project. Microchip embedded standalone, next, and the device we'll be using is PIC 16F877A. next, PIC 3. The hardware we'll be using is PIC 3. So that's what. If you're completely new over here and if you don't know how to download and install MPLABX and how to download and install the compiler, visit circuitdigest.com. Now select the hardware as PIC 3 and click on next. The compiler we'll be using is XC8. Click on next. Now the name for our project will be Blink. So this is where your project will get stored. Like I have saved it on my desktop and with the name Blink, so I'll just copy it and paste it over here also. And as you can see, it already creates a project folder with the extension .x. .x represents that it was created using MPLABX. So just click on finish. That's it, our project directories are being created. It's created over here. Now source file is the directory over which we have to place our C code. So right click on it, new, and C main file. I'll just paste the same name, Blink, and click on finish. So now this will be the area in which we'll be programming. I won't be using any of this existing code, so let me select all of them and delete it. So the next step will be setting our configuration registers. To set our configuration registers, go to Windows, PIC memory views, and configuration bits. So here we have our configuration bits at the bottom of our screen. Now the first bit will be the oscillator selection bits. Since we are using a 20 MHz crystal oscillator, we have to select this as HC. And second one will be the watchdog timer. I will turn it off, and power reset I will turn it off, and let it be on, and LVP will be off, and the rest will be off. Code protection and all those stuff will be off. If you're confused on what are these things and why are we setting it, I would ask you to go and read the complete write-up. I have completely mentioned why are we doing this. So once we do that, there's a button called generate source code. I think now you will be able to see it. So there's a button called generate source code to output over here. Just click it, and here we are. So our configuration registers are set and its corresponding pragma has been generated. So just copy it and paste it inside our C file. So that's it. Now our configuration bit setting work is over. So now for any program to begin, we have to start with void main, right? So let's start with void main and open parenthesis. It automatically closes for you. Now any PIC microcontroller program has to go on and on and on without any conditional limits. So we'll be using an infinite loop. An infinite loop is nothing but while of 1. So while of 1, open parenthesis and close parenthesis. Whatever we do inside this while loop will always be repeated. So while of 1 represents that the condition is always true, and whatever is inside this will always be repeated. Okay, now our while loop is ready. Now let's go ahead and tell our microcontroller that we'll be using the port B as an output port. To do that, I'll say it that tris B is equal to 0x00. This means that all the pins on port B is represented as an output pin. 0x00 says that it is an output pin, and if I want it to be an input, I'll say 0xFF. In that case, all the pins will be assigned as an input pin. This will say that I am using port B for output. Now just to make sure, we'll make all the pins to 0 on port B. this will make all pins. So the difference between tris B and port B is tris B will say, hey, I'm using that pin as an output pin, and port B will say, now that output pin is in 0th state. It can either be in 0 state, that is low, and high state, that is 1. Okay, now inside the while loop we have to keep on instructing the microcontroller to turn on an LED, wait for some time, and then turn it off again. So that's how a blink works. To turn it on, I have to simply say RB3 is equal to 1. This means the third pin of port P will be on, and then I'll turn it off. RB3 is equal to 0. Now what happens is it turns on and turns off in a fraction of a second that we won't be able to visualize it. So we have to add a delay in between it. So to add a delay, the syntax is underscore underscore delay underscore, the delay is in ms represents milliseconds, and I'll give a 500 milliseconds delay, and the same thing has to be used here also. So now I'll turn it on, wait for 500 milliseconds, turn it off, and again wait for 500 milliseconds, and this whole loop will be repeated. Now we also have, since we are using a delay function here, we have to instruct our microcontroller about a crystal frequency. So it doesn't know that we'll be using a 20 megahertz crystal. So let's go ahead and tell that to the microcontroller, like hash define define underscore xtell underscore freq frequency is equal to 20 megahertz. For megahertz it is 6 zeros, so 20 1 2 3 4 5 6 zeros. This means we are using a 20 megahertz crystal. 20 megahertz crystal. So that's it. Now our code is ready. Now let's go ahead and compile it. So we have to click on this icon, clean and build main project, to compile our project. I'll click on this and it's getting compiled over here, and you can see the message that it is build successful. Now let's create a Proteus simulation so that we can verify our output. Now I'll just minimize it, and as I said, our project is stored in the blink folder over here. So let's go ahead and open it. So blink.x represents that it has been created with MPLABX, and here inside the dist and default folder production we'll be having a hex file. So make a note of it because this is what we'll be using to run a simulation. Now let's open Proteus. And create a simulation. So I'll show you how to create the simulation over here. So this is how the Proteus looks like. Click on P icon. We'll be needing PIC 16F877A. Click on it. Okay. And we'll be needing a crystal. Quartz crystal is what we want. Click on it. And we'll be needing capacitors. We'll need 2 of them, so double click and click again. And what else? Okay, we'll be needing an LED. So to get an LED we should type LED active, and we'll get all the available colors. We have it in green, blue, red, yellow. So green is my favorite color. I'll just choose green. Double click on it. Okay, click here and we have our LED here. Now first we have to set up a crystal. So the crystal will get into oscillator 1 and oscillator 2 pins. So let's go ahead and connect it. So to make a connection, simply click on the arrow mark, sorry, not the arrow mark, the component icon, and then from the first pin connect the oscillator, from the second pin connect the oscillator. We also have to use two 33 picofarad capacitors. So 33 picofarad, just double click on the name and type 33 picofarad. That's it. So to move, just drag it let me place it over here. Again, to connect it, just click over here. Okay, that's it, a connection is made. Now we'll be needing the ground and power rails. Click on this terminal box and then you'll get a power. Let us go on power, our PIC MCLR pin. So MCLR has to be high, and we'll also need a ground. Double click here, ground. The cathode of the LED goes to the ground, and we'll also have to give a ground to this crystal oscillator. We have a capacitor. Now in our code we have connected, we have made the blink program to blink on RB3. So here it is, RB3. Let's connect RB3 with the LED. In order to instruct this microcontroller to run on our hex code, just double click on it. There's a folder option here where we have to load the program file. Click on it, and our program is stored on desktop. Remember, I asked you to make a note of the hex file, so we have to go and locate the hex file, blink.x, dist, default, protection, and here it is. So blink.x.protection.hex. Double click on it, click on OK. So now everything is ready. Just click on the play icon. Okay, now our connection is ready and we have loaded the hex file. We have to change one more thing over here, that is, we didn't mention that we are running on 20 megahertz frequency. Just double click on the crystal, mention that we are running on 20 megahertz, and the internal frequency will also be 20. Now just click on play, and now we can see our LED is flashing over here. As we said, on RB3 our LED should blink, and that's what is happening over here. So now we have successfully compiled this program. In our next video I'll show you how to do the same on a dot board. We'll be using a dot board and a real PIC 16 of 8777A PIC microcontroller and crystal oscillator, capacitor, LEDs and all those stuff. We'll be using ICSP to program our PIC. I'll tell you what it is in the next video. Thank you for watching.